Hello and welcome back everyone. In today's video we are going to learn how to create an obstacle course, write scripts, and rescan an existing template to participate in the Obby Game Jam. All the requirements and the rules can be found on the forum at the link below. So let's get started. Let's first open up Highrise Studio, right click and open. If you don't know how to install the studio, please refer to the link in the description which explains everything you need to get started. Once you open up Highrise Studio, click on new project and you will see here there's a bunch of different templates that you can choose from. Now our main goal is to use the obstacle course to write scripts and add some more obstacles. So I'm going to use the obstacle course. I'm going to give it a name. I'm going to call it Obby Game Jam. Create project and wait for it to load. Now that our project is loaded, you'll see here we have a template with different objects. Now we have also different folders, so if you navigate to template to expand that, you see here we have something called scripts and core traps. We have everything ready for you. So all we need is, or our main goal is to write scripts and attach them to the objects that we have in the scene. Now if you're new to scripting, don't worry because this series is designed to help you get started understanding scripting. So here are a few different scripts that we're going to write. First, you can see here we have different checkpoints. So there's checkpoints and there's also death trigger on each obstacle that we have. For example, the fall traps, the static traps, and we also have the moving traps. We're going to write a script for each one of them, and we're also going to write a script that tracks the players when they first join the game, so we can use it as a base script for our obstacle course. So let's get started with that. First things first, go to core, and in the core we're going to right click, create Lua, and we're going to create a module script. That's how we create script. So choose module and give it a name. Now the name for this script is going to be player tracker. Once you do that, hit enter and wait for it to load. So now that we have our player tracker, we simply double click to open it, or you can just open the entire project, but I'm just going to double click to open the script. So now that's done, there's something that I like to do all the time. Instead of opening the script by script, I like to right click on the assets and I like to hit show in Explorer. Once I do that, I click on the path right here and I type CMD. Now if you have Visual Studio installed or VS Code, you simply type code dot and this will open up the project in VS Code. Just like that. If you don't have VS Code, I suggest you install it, or I suggest you look at the videos that we have on how to get started with Highrise Studio, just to understand how to install all the tools that you need. Now there's one note here. If you go to the extensions and you search for Highrise Studio, you are going to find something called Highrise Studio Tools. This is crucial and it's really important to use because this will help us code. This will basically autofill everything for us, so you have to install this extension. So now that's done, let's go to the assets, template, scripts, core, and our player tracker. Now we are going to walk through a script that handles player tracking, which means it's going to handle the player tracking, checkpoints, respawning in our obstacle game. Before we get into the player tracker, first I would like to create all the scripts for you so things get easier. In the scripts in the core, we are going to create two more scripts. So go to create Lua, and the first one is going to be a client and server script. And I'm gonna call this finish zone script. Hit enter and wait for it to load. Okay, so now that our finish zone script is done, we are going to create one more script in the core and it's going to be client script. So create Lua and choose client and then call this script checkpoint. You can checkpoint script if you want, you can whatever you want, just checkpoint script and hit enter. Okay, so we go to the traps. Now that's done. Right click, create Lua, and it's gonna be a client and server script. Call this called trap script and wait for it to load. Okay, so now we have 4 scripts so far, and there's only one more script that we need for the other traps, which is also a client and server script, and we're going to call it death trigger script. Perfect. We have the scripts for the traps, 2 scripts, the death trigger script, the fall trap script, and in the core we have a checkpoint script, finish zone script, and a player tracker. So now the things are going to be way easier for us to, or clean for us whenever we start writing scripts, because some of them will rely on each other. Let's start with the player tracker. Now in the player tracker, what I like to do is to start with the main function, which is going to be the function for the client when it's awake, so awake, and function for the server initialization server awake. And I'm also going to create a table, and this table is going to a global table and it's going to call it players, and also going to create a local function. I'm going to call it player or track players. This function is going to take the game and is also going to take the character callback. I'm also going to call that function inside the client awake, but I'm going to pass the client inside the function because of the game, and the same goes for the server, but I'm going to replace the client with server. So that's done. I'm also going to do something inside the player tracker in a second. If I go inside the player tracker and I type game.player connected, this is gonna let me listen to the event whenever the player connects to the game. I'm saying game because we passed in client and server, so whenever a player connects to the server, it will be logged, and whenever a player connects to the client, it will also be logged. If I hover over client, you can see here that the client takes the property player connected, which is an event, that allows you to listen to by using connect, the method connect. And there's also another method that we can use, which is the player connected. And this will also be the player that we have. That's the setup that we're going to be using right now. Now, to get things done with the client, I am going to require declare a variable for the UI controller. This will help us set up the basically the HUD. So I'm gonna say local. I'm gonna call this my UI controller. And it's going to be nil because we basically don't need to assign anything right now. Instead, we do it in the client. So whenever the client is awake, we basically say my UI controller equals self.game object get component, and we're also going to get the obstacle HUD that we just created, which is if we hover over the UI folder, you can see here it says obstacle HUD. So just pass in obstacle HUD in there. Now, if you go back to the track players, we are going to assign or insert a new player every time someone's joined, because we already have a table that basically track all the players, right? So I'm going to say here players equal, and I'm players player equal player and stage equal value. Oops, sorry. New stage. I'm gonna convert to string, and we will explain that in a bit. So now, whenever a player connects to the server or the client, we are adding them to the table by giving them a key, which is the player. And this exact key holds the player, which is an object, and also the stage, which is an integer value that is a network ID, and I gave it a name stage. And to make it unique, I also converted the player ID to a string, and I set it to 0 by default. So the stage would actually look something like this, like for example stage 1, stage 2, and so on. So each player has their unique integer value. And now later on, if someone's changed their value or their change or the stage, or they hit a checkpoint, we basically listen to this integer value. There's more to the documentation if you want to check that out. So now that we inserted the player when they join, we want to remove them when they leave. So we're going to do the same by doing players player equal nil. This will basically remove the players because we are getting the key, which is the player that just left from the players table that we just created earlier. And now we're also going to listen to another event, which is the character change. So player.character changed. This is always how you connect to events, by doing connect. And this function, or this event, takes the function that has the player and the character of the player. So we have to double check a few things here. First, let's get the player information from the player table. So we're gonna say player info equal players and the key, which is the player. And then we're gonna say if character equal nil, which means that there's no character, then we're going to return and we're going to exit the function. And now we're going to use the character callback that we used before. So we're gonna say if there's a character callback, then pass in the character callback and pass in the player information and end it. And just to make things look a little bit better, you can put this here and this here. And there you go. So now that when a player joins, this basically is going to insert them to the table with the players table with an integer value that's a network. Also, it's a network value. And then whenever the player or the character change, we are also calling that callback that we just called before in the tracker player function. So now if you go to the client awake, which is the most important part right here, but that tracks every move or every every stage the player passes. So we're going to create a new function here, and this function is going to be on character instantiate. Sorry, I hate that word. The function on character instantiate. I also hate the way you write it, but and this will also take the player information because we already passed in the player information in the character callback right here, so we're just gonna pass it right here as well. And the track player, since we are passing the character callback, we have to put it inside the tracker players. We have to pass it in as a second argument. So I'm gonna say here on character instantiate, and I'm also going to remove the player information, and that's because just by passing the function itself, it will automatically get the player information since we are already doing it over here in the other function. So now this on character instantiate function, we are basically going to get the player by doing player information, and then player, because we are basically saving the player object inside the players table. And then to get the character, it's gonna be the same player.character. Now here we can check if there's no character we can return, but we don't need that because we are already doing it over here. So now we're gonna listen to the player stage whenever it's changed. So player info dot stage dot changed. Actually changed is it's uppercase. And we're gonna connect, and this will take the new value and the old value. I'll explain that in a bit. But this means that whenever someone pass a new stage and we pass in a new number over here, it will basically tell us that this player has passed this stage, and it will give us the old value and then the new value of that stage. So now we are going to say if the player is equal to the client.local player, then we are going to print, and we're going to say that the client local player.name is on, or has a new stage, is on stage, and then we can just convert that value or that stage to a string, and we can pass it in here just to see whenever the player hit that stage or whenever the player move around. So now that's done, let's scroll all the way up, and we're going to create a new serialized field here, and this serialized field is going to be the checkpoint sound. So we're going to say local checkpoint sound is going to be an audio shader, and it's gonna be nil, so it's initialized as a nil, but then we change this value inside the unity. And if we scroll down to the player info.stage change, that means this is whenever the player actually changed their checkpoint. So whenever the player hits a checkpoint, we basically want to play that audio for them, right? So we can call the play shader method inside the player info.stage.change. So this could be called inside of here or in the player info. I'm gonna call it inside, so only the player hear it. So whenever it changes, only that player will hear that audio. So we're gonna say audio, and we're gonna use the play. Yeah, I think the VS Code extension is not updated. So, but that method actually works. So it's play. I think it's play cap uppercase and then shader. Yes, I think that's the method. So pass in the checkpoint sound, and this will basically play the play sound. Don't worry about the lines that you see here, the red lines. This will work. It's just the VS Code telling us that not found component type, but it is. It's actually a thing. Okay. So now I'm going to create more serialized fields for the checkpoints. So I'm gonna say serialized field and local check. It really depends on how many you have. I'm gonna say local checkpoint 1. And it's going to be transform, and it's also going to be nil. And instead of repeating this all over and over again, actually let me just this and paste that. Instead of repeating it all over again, I'm going to copy and paste it 5 times over here. We have 1, 2, 3, 4, and 5. And I'm also going to wrap all the checkpoints that we have inside a table just to make things easier for us to just loop through them and just basically get that specific checkpoint. So I'm going to create a global table. I'm going to call it checkpoint transform. So checkpoint transforms equal to all the checkpoints that we have right here. So checkpoint 1, and then checkpoint 2, checkpoint, checkpoint 3. Okay. I'm sorry, I just have this very small keyboard, which is really annoying when it comes to using the arrows. And there you go. So now we have a table that stores all the checkpoints. Now, to show you what the checkpoints are, if I go back to Unity, Okay, so now in Unity, if I zoom in, let me just get rid of the nav mesh. Okay. So you see here, we have checkpoints, and this is checkpoint 1, this is checkpoint 2, 3, 4, and we also have a finishing zone. Now, all of these are checkpoints. If I click on it, you see here, top right, in the inspector panel, there's something called transform, and that's exactly what we are trying to get. Because each one of them has a different transform. And we want that transform so we can send the player to that checkpoint whenever they die or whenever they want to respawn, if that makes sense. So let's go back to coding. And inside here, we are going to have 3 different events. And the first event is going to be to update the stage request. So I'm going to say local update stage request equal event new. And I'm just going to copy and put this inside of here. And I'm going to have 2 events, one for the respawn request and one for the response. Okay. So local respawn request equal event.new, and that's also going to be this thing. Oh. And then local respawn response. Now this might be a little bit confusing, but don't worry, we will get it. We'll get there. And there we have 3 events. Now this event is going to be used to tell the server that this player has changed their, their position or their stage, right? So we're going to scroll all the way down to the client awake, and we're going to create a function inside the client awake. This function is going to be update stage, and this function will take the stage that we're going to update. So let's say new stage, right? And inside the update stage function, I'm gonna say update stage request, which is the event, and I'm gonna fire it to the server, which will take the new stage that we just fired, right? Or the new stage that we just got from whoever used that function. Because remember when I said the player tracker is a module that can be used anywhere, I can later on use this update stage whenever a player hit a checkpoint, if that makes sense. So now since we fired the event, we have to listen to it. So let's go back to the server awake and let's do update stage request and connect function. Now, since we fired it on the server with the value, basically first it fired with the first argument is always going to be the player. So player, and then the new stage that we just got, right? And now that we have the new stage, we basically want to update the player. So we're going to say player, which is the key of the player, and then dot stage, yeah, dot value equal the new stage. And just to make this a little bit more clear for you to understand, I'm going to say local player info equal player, right? And now to change the player stage, we are going to say player info dot stage dot value equal the new stage. So that's it. So basically, we created a new function that takes the new stage, and we fired an event to the server with the new stage that we pass, whatever stage we pass here. For example, we can pass 1, we can pass 2, 3, 4, whatever you want. And then when we fire that event, we are actually listening to that event in the server awake. So which takes the player that fired the event and the new stage that we just sent. So we basically get the player information by doing players with the players as the table, and then the player is the key. And then if you remember, if you scroll up here, we created an integer value, which is a network value as well for the stage. So that's how we access it, by doing .stage.value, and we override it with the new stage. Okay, so now that we have created the update stage function, we are also going to create a function that handled the respawn. So function respawn player, you can call this whatever you want. I'm gonna call it respawn player, and we're gonna get the stage of the player by getting the player itself from the players table. And again, it's always going to be client.local player. So players table that has the player itself, which has the stage, and then to get the stage, we get the we use the value property. And then if the stage is 0, then we are going to send them back to the spawn point, which is going to be a vector3 0 0. So you can say local spawn if you want equal vector3 dot new 0 0 0. This is the point where the players spawn at first. And then we're going to fire an event, which is the respawn player request. We're gonna fire it to the server, and we're gonna be passing the spawn the spawn point to the server, and then we're going to return because we don't want to else do anything else. But if the stage is more than 0, we are basically going to actually, yeah, respawn request and fire it to the server, but this one will take something different. So here, to get the position of the stage, we're gonna say local pose equal local pose equal, and the checkpoint transform, which is the table that we created earlier, and the key is going to be the stage, which is the number, and then the position, and we're gonna be passing the position in the respawn request. Now, to give you a quick summary of what I did here, basically, I got the stage, which is from the player's table, and the key is the client.local player that we always do. We pass in the player as a key, and then the stage. And just to make things a little bit more, a little bit easier for you, I'm gonna say local player info here equal players client.local player, and we can say the stage is going to be player info dot stage dot value. Is that better? Okay. So the stage is going to be the player info dot stage dot value, and we're gonna check if the stage is 0, meaning that the player hasn't hit any checkpoint yet and they are still in the spawn. So we send them back to the spawn, and the spawn is vector 3, and ignore the red line. This is because of the extension. And we send an event to the server, and we're gonna be like, okay, so the player is stage 0, so get them back to the, send them back to the spawn, right? And then if the stage is more than 0, we basically, or even if the stage is less than 0, this applies as well. We create a new variable, we call it pause, and we get the checkpoint transforms, which is the table right here. And the key is stage, meaning, for example, if you have stage 1, it's going to be 1, 2, 3, 4, and so on. And then if I look down at the fire server, we fired here at the spawn, and then we fired the position. And the position is because we only need the vector 3, which is, if I go back to Unity right here and I check on this checkpoint, you can see here that this is the transform, and the transform has a position. That position is what is where the checkpoint is at. So whenever someone dies, it would just send them back to this specific checkpoint. Now that we send the event, we request the event, we have to listen to it and send it back. Like when we send it to the server, we have to listen to that event. So we're gonna say respawn request connect. That's how you listen to an event, and this takes also the player and the position of the or the position that we passed earlier. So we're gonna say player.character.transform position equal to the position that we just got from the client, and we're also going to send a response back to the client. Like, let's say we received a request from the client, and we listen to it on the server, and then we're gonna be like, okay, so we received this request, go and update all, like, this player to all the players who are in the game. So we're gonna say respawn response, that's when we use it, and we're gonna fire it to all the clients, and we're gonna be passing the player, meaning when we got the event, which is the respawn request, we changed the player position, we set it to the position that we sent from the client, and we also fired this event to all the clients, to everyone who is connected, and we passed in the player because this is the player that we want to update. So if you go back to the client awake, now we can listen to the respawn response. So respawn response, connect, and again, this is going to take the player because we send the player, and we're gonna say local stage equal players, or again, just to make things a little bit better for you, I'm gonna say local player info equal players, and then the player, right? And then the stage is gonna be equal to the player info dot stage dot value. And then again, if the stage is 0, then end here. We're going to say, one second, hold on. Okay, so player.character, and we're gonna use the teleport function, the teleport method to teleport the player to vector3.new 000, and just to make things look a bit better, I say local spawn equal vector3.new 000, and then you can pass in the spawn inside the teleport function, and then we can return and we can end. But if the stage is different, if it's not 0, it's more than 0 or even less than 0, we're basically going to teleport that player to that position of the stage. So we're gonna say the same thing. So local pose equal checkpoint transforms, and the stage, which is gonna be the key, and the position, and then pause and player.character again teleport. The method teleport, and we're gonna pass in the pause right here. And that's it for the player tracker. Now we have everything. We're tracking the players, we are tracking their positions, and we have a respawn and audio shaders and an update stage and everything. So that was the hard part. This is the only thing that you have to understand the most. Now that we created all of the functions, we can start using them in our checkpoint script, finish zone script, and the trap scripts.